Okay, welcome to lesson 11.2, proving figures are similar using transformations. Okay, so again, I will let you read that explore section on your own, but similarity, basically, you're preserving a couple things, right? You're preserving the internal angles, right, are the same. You're preserving the basic general shape is the same, and there's a certain scale factor from one shape to the resulting shape. And so one thing that I do want to point out is that you can apply it to each of the values in the ordered pair to help you do that. And there are a couple things that you may or may not remember from previous credits that will be applied here, so just be ready for that when the time comes. Okay, let's go ahead and jump to the your turn questions here. We have 3 questions and 4 choices, so one of these is obviously really off. Okay, so we have to match the description to the transformations. Okay, so I am going to go the other way. I'm going to match the transformation to the description. I think that's the easier way to go for this particular one, from PQRS to TUVW. Okay, so we're going from this original one to this resulting one. Okay, so automatically, we're like right off the bat, this tells me that the scale factor is going to be between 0 and 1. Okay, because we're getting smaller. Take a look at that. We're going from the PQRs to TUVW. The shape is getting smaller. Okay, so let's see which one of these has a scale factor that is less than 1. Well, this one has one that's less than 1, and that's it. That's the only one. So this is going to be our answer, really. And if we read the rest of the description, we see that it's true as well. The reflection across the y-axis, so we reflect it across this way, and then it does get smaller by 1/3. Okay, so there's that. So taking a look at the second transformation, again, I'm gonna describe it in my head and then go from there. But ABCD to DEF, so obviously going from here to here, the dilation, the scale factor is greater than 1. Okay, it is getting bigger, but quite a few things are happening here, right? And it does take a little bit of 3D spatial reasoning to understand what's going on, but generally what I can tell you is that look at this, for example. The distance from this point here to where that point end is, right, is 2 away from the same x value, right? Whereas from okay, so going from shape 1 to the resulting second shape, right, there's some kind of rotation going on here, right? So there's a rotation that's going on kind of clockwise here, 180 degrees around the origin. Okay, but also then there's that dilation, right? That's what it looks like to me, at least. So let's go ahead and take a look at these. The only one that of the remaining 3, right, we've already done that, the only one of these that talks about any kind of rotation is this one, right, C. Right, so I'm going to say that this is C. Okay, and then lastly, ABCD to EFH, right? This is the original, this is the resulting new one. So we see some kind of reflection that's happening here, okay, across the x-axis, and then it gets bigger. Okay, so we want to see a scale factor in the description. And so sure enough, if we look at choice B, it's a reflection across the x-axis, whereas this one is the y-axis, so this is not the right one. And we can say with relative confidence that this is B. Now, one thing I do want to mention, as I was kind of answering these, I just kind of used the process of elimination. But as you'll find out a little bit later, if we were to take each individual point, for example, if we were to take all the individual points of, for this second one, by the way, and take A, B, C, and then we were to write A is 2 comma 1, negative 2 comma negative 1, and then going from there to, let me see, B is negative 6 comma negative 1, and then C is at what, 0 comma negative 5, and then if we were to rotate around the origin and all that, this description is actually kind of off, right? In fact, we actually went 3 units to the left and 1.5 units up. So we wouldn't have known that though if we were doing it, unless we were doing it by the ordered pairs. But either way, C was probably your best option anyway. So if you didn't get C for this one, what I'm basically trying to say is just give yourself some grace. Technically, you're right. C is not a good description, or not the accurate description, but it's the best one we got.